Hi, I am Arunabha. So this is one of my final projects for AME 69700 Computational Fracture Mechanics. So the title of this project was Modeling of a Moving Heat Source on a Shell Element. So this is actually a transient analysis on a shell element in Ansys APDL, that is the Ansys parametric design language. So I had used a shell element in Ansys APDL. These were my objectives of the project. So I would give a brief overview of transient thermal analysis. Then I would like to discuss something about the shell 131 element. After that, I'll come to the ANSYS parametric description language, the APDL work environment. Then I'll show the modeling process in APDL, the results, and I'll provide some conclusions based on the project. So transient thermal analysis. So transient thermal analysis is actually an analysis that determines quantities varying over time, like temperature, temperature distribution results, or such things can be plotted which are not static, which depend on time, which change with respect to time. So thermal stresses can be plotted. And this type of analysis can not only be linear but also can be non-linear. So this type of transient analysis can solve problems such as heat treatment problems, electronic package designing problems, fluid-solid interaction problems. In many types of industries like pressure vessels, that type of problems can also be solved using transient thermal analysis. But usually this analysis is non-linear because, as I told, it varies with respect to time. It's not static, so this has to be non-linear. So let's discuss about the shell 131 element. So in Ansys APDL, among the elements, there is one 3D layered shell element, the shell 131 element, and this element has the capability of through thickness thermal heat conduction. So this has like 4 nodes, and at each node there is about 32 degrees of freedom. And then this can the output temperatures that we get after solving problems using this element, this can also be used in modeling thermal bending problems in solid structural elements. So this is the pictorial representation of the shell 32 geometry. As we can see, the layer 1, layer 2, these are the layer temperatures, TTO, PT, 4T, 3T, TTB, OT. This is the bottom layer temperature, this is top layer temperature. So actually the purpose of this project was to determine these layer temperatures actually and compare between the values of these temperatures. So Ansys APDL stands for Ansys parametric design language. Ansys parametric description language. And input parameters such as element type, material models, material properties, and other input parameters like real constants, which like thickness of material, these can be given as input to get the desired results like nodal displacements, stresses, strains, list of stresses at nodes, deformed shapes, deformed edges. So this can be generated as output in Ansys APDL. So this was the mesh after meshing the shell 131 element. This was the mesh that was generated. So as we can see, there is quite a fine mesh with very small elements, rectangular elements, and this is like quite well meshed, so there shouldn't be any issues with this kind of mesh. So these were how the nodes were plotted. Like in the plot option, there is plot nodes, and we plotted these nodes because we want to simulate a moving heat source. So it's like the source will be we'll define the kinematic properties, but then we have to define each nodes as the heat source will move from one node to another. So this is how the nodes were plotted. Then I applied the load. A load of about 250 magnitude was applied till node 7 till here, like this. So this load was actually the thermal load which is required for the transient analysis. This was the result of the nodal temperature TBOT. This is the bottom layer temperature actually, and this is the layer temperature, and this was the output after plotting the nodal temperature from the general post processor option. This was generated. So as we can see, the maximum value is about 28155. It's like at the center and at the very bottom, and then it actually decreases as it goes upwards. So this was the moving heat source simulation in 5 frames. This was done in 5 frames with substeps of each substep was like added on to 5 steps in total. And as we can see, this is an intermediate position where this is the temperature, actually temperature, distributed values of temperature we find here. So regarding the conclusion, I can say that the value of temperature when we are doing the moving heat source simulation, it does not depend on the position of the node or the location of the node. And the layer temperature TBOT we found has the highest value of temperature among the 3 layer temperatures TBOT, TTOP and TE2. The value of temperature also increases with each substep or each time step, and the highest value was recorded at node number 7, about 28155. So this was a brief description of the project that I done on in Ansys APDL about the transient heat transfer analysis.